So the first talk was about detecting people so they can smoke less. And the second one will be for people to sleep more so that they can miss sessions in UbiComp. Right, okay, so Rajesh, take it away.
Thank you. I don't like standing behind podiums, so I'll just walk around. Okay, so this is joint work with my student, Camellia, who tragically could not make it because she's starting a job, and that's more important coming here, right? Instead, you took a photo. I need to send it to her. No, make her feel bad. But okay, what we're going to point out is how do you detect sleep with no devices at all? Absolutely no devices. We don't give anyone anything. We don't install apps. Okay, so how do you detect time of sleep, length of sleep, time of wake up, right? Which is important for many, many different health metrics, by the way. So as we all know, sleep is a huge cause and effect of a lot of physical and mental health issues. It is both the cause, it's also the effect. And accurate sleep monitoring is one of the most important things doctors will ask you, actually, when you go for any kind of diagnosis. They'll ask, how much have you slept? And of course, nobody knows, right? Everybody makes up a number, right? And in colleges, this is particularly important in dormitories, etc., to figure out if your assignments are crazy, if your exams are working, if your wellness programs are working. This is part of what we need to be able to say anything about how well our wellness programs are working. Elderly, every age group, you need to monitor their sleep. But it's really, really hard. Okay, this is where we are today when it comes to sleep monitoring. We have 1 million smart devices. They all work, but they're completely disconnected from each other. Every ecosystem is different. You have the Oura ecosystem, you have Google's ecosystem, you have Apple's ecosystem. They all don't interoperate. Trying to make sense of anything at scale is really hard for those of you who have been in this area and tried to do it. And of course, once it comes to a device, people forget to use it, right? They're like, I don't charge it, I didn't turn on the phone, I didn't install the app, a dog ate my phone. All kinds of strange reasons come out if you've actually worked in this area, right? I see some of you looking at me and going, yeah. It's really, really hard to collect sleep data at scale. And at scale, I'm talking hundreds, thousands of people, not talking tens, right? 10 people, sure. 20, sure. How do you do entire campus dormitory, right? Where you're talking 10, 30, 40,000 students, right? How do you do that? Well, the other way is you do it without any devices or any apps at all. You use things which are already generated automatically and unconsciously by humans. This is important. It has to be unconscious, it has to be automatic, which means it doesn't change their behavior. Almost every other sleep tracking system we've seen changes somebody's behavior. They have to wear something, which can be uncomfortable. They have to turn something on. They have to install something, right? So how do you do it? What is the magic? Okay, the magic is this wouldn't have worked 10 years ago. It works today, and it works for all of you, right? The magic is this. The first thing you do when you wake up is you touch a device. All of you ask yourselves, do you touch a device when you wake up? Yeah, probably to turn off your alarm, right? Or to look at your phone or your watch for whatever reasons, right? Or your tablet. What is the last thing you do before you go to bed? You touch a device as well. Why? Final, I'm going to bed WhatsApp. You post on X, you post on Instagram. Like many of us, you check your email to make sure that killer email that changes your life has not come in, right? All of us believe that that email was going to come in. We have to check, otherwise we might miss it, right? Because it comes in a 5-minute window, as we all know, right? If you don't read it within the 5 minutes, it goes away. Right, so what do you do then? The problem now becomes how do you find the gaps between these events, okay? And the reality is it's not usually your phone. It could be different things. It could be a tablet, could be a watch, could be a laptop. So think about it, you touch a device. Okay, this is important because it's not just your phone, as we find out. It's all devices, right? So you need a method that works across all devices. So what we do is we have turned the problem from installing devices to observing the behavior of your devices, to find the gaps. On the y-axis here is network traffic. On the x-axis is time of day. When a device is active with a human using it, it generates a lot more network traffic. That is because all your apps are now in foreground mode, and they're all active. When you turn off your screen, your apps go to sleep, by the way. This is true for iOS, this is true for Android, and they go to background mode. They still get updates, but less. The moment your screen turns on, they all get an awake message, and a lot of messages come up. So we turn the problem into trying to detect the gaps. Where your phone shows, or your device, or your watch shows less activity indicative of sleep. Seems easy, right? in practice, it's not actually that easy for various reasons. One is that your phone and watch is actually not silent at the night. You know, you're getting a lot of WhatsApp messages, access, you know, OS upgrades, all kinds of things, which also generate traffic, right? The user, you know, there is still a gap between when you touch your device and when you actually fall asleep. I mean, it's not automatic. I mean, if you are great, you have great sleep habits. Most people, it's not. You lie in bed, you know, you toss and turn a bit. So you still have that error there. And of course, you can have missing data, right? Because for various reasons, you just don't get data. You know, this is true with any kind of data collection system. Sometimes you just don't get data. You know, you're at the beck and call of the power-saving mechanisms of Apple, Google, Samsung, etc. So sometimes your phone just doesn't send data, or watches don't, because of some power-saving mode. Okay? So how do you actually operationalize this? Well, it now becomes a classification problem. You need to be able to look at these things, and then you actually have to be able to label whether the person's awake or asleep. So we turned into a binary classification problem, right? And we add every device. The key here is because we're doing this with Wi-Fi, we are not collecting the signals with any app on the phone. We're collecting it directly from the access point, which means we're collecting every single device. We don't actually care what you're doing. You know, we don't read the packet signature. We don't look at the packet at all. All we're doing is the presence or absence of a signal. That's it, right? But we're getting it for every device. And now we are trying to classify whether the person's actually asleep or awake. So, you know, mandatory gory systems diagram, because this is a systems paper, right? So we have the Wi-Fi coming in, collected from the access points directly. We go into feature extraction, extracts lots of things. You know, then we have a whole bunch of machine learning models. There's no deep learning here, because even at 10,000 users, you can't train a deep learning model. It's still overfitted. So this is classical machine learning, right? And we do a whole bunch of stuff, right? So does it actually work? We have 46 students that we actually tested this with. And yeah, the accuracy is actually great. Okay, we have accuracy, precision, recall, all great. Most importantly, our ground truth is the Oura sleep ring, which is a state-of-the-art sleep ring. And our metrics are exactly the same. We don't get the same numbers where you're statistically no different from Oura, according to any metric you want. Quartile 1, max, median, mode, everything. With no devices installed, right? So with no effort, we can actually get great predictions for everyone, right? And we can figure out if you actually have split sleep behavior, etc. We actually do better than Oura in some cases, right? We didn't control for the students in any particular way. Okay, so the key takeaway, right, for all of this is that we have a way to detect sleep at scale. Now, what are you going to do with this? This is just a technique now, right? A technique without any use case is kind of useless. So I'm actually trying to deploy this on my campus to see if our students are happy, right? If our students are actually well rested before exams, you know, because I'm trying to build a way to change our entire curriculum. Because people always have many ways to change curriculum, but they're not data-driven, right? It's like if you have exams scheduled in certain ways, are students well rested? Or do you need to change your exam schedule? Do you need to change your assignment schedule? You know, I'm talking to people in military camps to see, are they fit to train today? Because you don't want to give people live ammunition if they're actually not rested, correct? So these are sort of things. So this is a tool, you know, and I offer it to everyone here. What would you do with something like this, right? If you had a way to detect sleep at scale. Now, it doesn't do sleep quality. I mean, with weak Wi-Fi, if I could tell you sleep quality, that's really black magic, right? But it gives you level 1 metrics. Time of sleep, time to bed, duration of sleep, time of wake up, which is good enough for many first-level analytics. Okay, and with that, I will end. Any questions, please email my student, or you can email me as well. Come find me. I'm here until Friday. Yeah, so thank you.
Okay, Gregory.
Yeah, Gregory.
Yeah, so great talk. Could you quickly tell us how you, in a dorm situation, differentiate the different individuals? Because they're sharing the same Wi-Fi access point, and they have lots of devices.
Yes, because my core background is actually indoor localization. If we wanted to, this is a very interesting question. I was actually asked by some of my dorm operators, can you tell me who's in what room? I didn't want to get involved in that at all, because we actually can. Based on the location, from seeing from multiple access points, I can actually locate where the devices are. Very accurate. But I didn't want to get into
Well, what if their laptop is in the study room and their phone is near the bed?
We kind of ignore laptops. In many cases, laptops are our least reliable device. We look at phones, we look at watches, because you will never leave your phone behind. Students never leave their phones behind.
Thank you. You have a quick question, or can you reserve that for later? Okay, great.